Okay, so good afternoon to all. Let's start today's session. So, generally, in uh, last lecture, we again solved the example of KMAP, but in that example, we solved the example of KMAP with a don't care condition. Okay, so you can let me share my screen. So you can see my screen. So this is the example which we solved in last example, last lecture. So in this example, uh, we again solve the example of four variable KMF only, but in this we have a don't care condition. So what is the don't care condition and how we have to solve the example with don't care condition, that we see in the last session. So we solve the example of POS also, and we solve the example of SOP only. So as I already told you about that, the don't care we have to consider, or we have to put mark by a x, and we have to consider a don't care x is equal to either 1 or 0. X is equal to either 1 or 0 if and only if it is useful to reduce the function. If it is useful to reduce the function, then and then we can put the value of don't care is equal to 1 in a SOP function or a mean term example, and we have to put x is equal to 0 in the POS function or a max term function. Okay, so this is the example we solved in the last lecture, one with the mean terms and another with the max terms. Okay, and if we have all the 16 possibility, so either if there is an example of SOP, if there is an example of SOP, then we have to put 1. If all the 16 is equal to 16, we have to consider in a group. And if there is an example of POS, then we have to put 0. Then we have to put 0. Okay. So let's start today's session. Today we have to learn about the another method, which is known as the QM method, or you can say its name is tabulation method. Again, this QM method is useful to reduce the function only. Okay. Uh, so the QM method is useful to reduce the function only, and its name is QM because the full name of the QM is Quinn-McCliskey. It is Quinn-McCliskey method. But generally, we know this method by using the tabulation method. Generally, we know this method by using the tabulation method. So how to solve the example or how to reduce the example by using a QM method, or you can say tabulation method. Again, there are certain rules to solve the example. To solve the example by using the QM method. To solve the example by using the QM method. Okay. It will be asked again in GTU for 7 mark, but it is somewhat difficult compared to the KMM. Okay, because we have to follow the certain rules. Now, which are the rules for the QM method? Let's check it one by one. Okay. Okay, so fundamental idea for the tabulation method is combining theory. What is combining theory? You can see, suppose we have PA plus PA dash. What that answer is? Suppose we are taking P common. So A plus A dash. So A plus A bar is equal to 1, as we all know. So the answer is P. Okay. So this is the general combining theory. So now we have what we have to do. Okay. We do not have to focus on this. Let's start the method of the tabulation method, or the rules for the tabulation method is, suppose in given example, we have the numbers of min terms. So what we have to do, we have to list out all the min terms. We have list out all the min terms. Then what we have to do, we have to arrange all the min terms. We have to arrange all the min terms in a group of the same number of ones. Suppose what we have to do, we have a min term 0, 1, 2, 7, 8, 9. Now we have to convert those min terms into its binary conversion, into its 4-bit binary conversion. Okay. Again, I am repeating what we have to do. Suppose we have a numbers of min terms given in the example. We have a numbers of min terms given in the example. We have to convert those min terms which is given in the example into its 4-bit binary representation. Into its 4-bit binary representation. Okay. So we, after converting those min terms into a 4-bit binary representation, we have to arrange all the min terms in group. So how we have to arrange all that min terms into a group? So in the group we have the min terms which having a same number of ones, which having the same numbers of ones in their binary representation. Okay, what that means, let me give you the example so you can easily aware about that. Suppose I have a min term 1, 2, and 8. So these min terms are in a single group. Why? Because if you are converting 1 into a binary, suppose you are converting 1 into a binary, then your answer is 0, 0, 0, 1. Suppose if you are converting 2 into binary, then your answer is 0, 0, 1, 0. And suppose if you are converting 8 into binary, then your answer is 1, 0, 0, 0. See, all these min terms having same numbers of ones in their binary representation. In one, if you convert 1 into binary, the number of ones, we have to focus on only numbers of ones. Okay, only numbers of ones. So numbers of 1 available in a 1 is 1. The number of 1 available in 2 is on, again, if you check, number of 1 available is 1. And number of 1s available in 8 is also 1. So focus on this. We have to arrange all the min terms in a group of the same number of ones. Same number of ones in their binary representation. In their binary representation. Okay. So we have to start with the least number of ones. We have to start the least number of ones. So what we have to do, let me show you. Suppose this is our given example 0, 1, 6, 7, 8, 9, 13, 14, 15. Okay, again I am repeating the rule first. Okay, we can check rule by rule, so then you can easily aware about that. So list all the min terms, and we have to convert all the min terms into its binary form. So these are the min terms which is given in the example. You can see 0, so convert into a binary, so 0, 0, 0, 0, 1, 0, 0, 1, 6, 0, 1, 1, 0, 7, 0, 1, 1, 8, 1, 0, 0, 9, 1, 0, 0, 1, 13, 1, 1, 0, 1, 14, 1, 1, 0, and 15, 4 times 1. Okay, so first rule is list all the min terms. So I think it is clear. Now we have to make, or we have to arrange all the min terms in a group. All the min terms in a group of the same numbers of ones. Of the same numbers of ones in their binary representation. In their binary representation in column 1. And we have to start with a least number of ones in a group and continue with the group of increasing number of ones. So starting in 0, we do not have any 1. So that table is known as the index. So we have to start with index 0, then index 1, then index 2, then index 3, and then index 4. Okay, maximum possibility is 4 ones. Maximum possibility is 4 ones, and minimum possibility is 0 ones. Because in 0, the number of 1 is 0. So index 0 means number of ones is 0. Index 1 means numbers of ones is 1. Index 2 means numbers of 1 in a binary representation is 2. Index 3 means numbers of 1 in a binary representation is 3. Okay, so start. Arrange all the min terms in a group of same number of ones. So you can see index 0. Index 0 means number of 1 is 0. So min term is 0, no 1. Index 1. Index 1 means numbers of 1 available in binary representation. Numbers of 1 available in binary representation are 1. So which are the min terms? You can see numbers of 1 which is 1. So you can say this 1 and 8. Okay, make a group of that 1 and 8. Okay, then index 2. So index 2 means the min terms which having a 2 numbers of ones in their binary representation. The min terms which having a 2 numbers of ones in their binary representation. So you can see a 6 which having a 2 ones, 7 we have 3, again 9 we have 2. So 6 and 9 again make a group. Then index number 3. Index 3 means the numbers of ones available in their binary representation is 3. The numbers of ones available in their binary representation is 3. So you can check in 7 we have 3 ones, in 13 we have 3 ones, in 14 we have 3 ones. So again we have a group of that 7, 13 and 14, and index 4 means we have a binary number, we have a binary representation which have a 4 numbers of ones, so there is only one possibility is 15. There is only one possibility is 15. Okay, so we have to arrange it. We have to arrange it as group wise. Okay, and how we have to make group? You can see index 0. Index 0 means numbers of 1 in a given min term is 0. So if in our example, if in our example 0 is given, then and then there is a possibility of index 0. Then and then there is a possibility of index 0. And if in our example, if 15 is given, then and then there is a possibility of index 4. If in our example 0 is not given, that means we do not have to write index 0. We have to start with index 1, index 2, index 3, index 4. And suppose in our example 15 is not there, then we do not have to write index 4 also. Then we have to just write index 1, 2, and 3. Okay. So now anyone having any doubt about this column 1? Anyone having any doubt in column 1? Again, I am repeating, what is the rule 1? We have to list all the min terms which is given in the example and convert those min terms in their binary representation of group 4. Then we have to make a group of those min terms. And how we have to create a group of those min terms? We have to arrange all the min terms in a group which having a same numbers of ones, in their binary representation, which having a same numbers of ones in their binary representation. Okay, in column 1. So this is our column 1. So we have a index 0, index 1, index 2, index 3, and index 4. And how we have to arrange it? Starting with the least numbers of ones, from the highest number of ones. Starting with the least number of ones to the highest number of ones. So least number of ones means starting with 0, and highest number of ones means all the 4 are ones. All the 4 are ones. So anyone having any doubt in this, how to make a column 1? If it is no doubt, please write down a clear, then I will move forward for the second rule. Okay. Okay, so let's move for the rule number 2. Okay, again move for the, let me remove these all things. Okay, so now there is another rule. Okay. Now what is that other rule? So now we have to focus on that. It is very important. Now we have to make a pair. So how we have to make a pair? So okay, after group rule number 3, again we going to the example, and then we can see how it will be done. Okay, so now what we have to do? We have to compare each term of the lowest index group with every term in the succeeding group. every term with the succeeding group. So we have to make a pair with index 0 with index 1 only. We are not focused for the index 2 and index 3. So index 0 with index 1, index 1 with index 2, index 2 with index 3, and index 3 with index 4. So what is rule? Again, I am repeating. Compare each term of the lowest index group, sorry, lowest index group with every term in the succeeding group. So whenever possible, combine the two terms. So how we can combine the two terms? Being compared by means of the combining theory. Okay, so we have to focus on the combining theorem. So how we have to combine? Okay, so two terms from the adjacent groups are combinable. Two terms of the adjacent groups are combinable if and only if their binary representation differs by just a single digit in the same position. Okay. So we have to check the binary representation. If the binary representation, are changed by only a single bit, are differ by only a single digit, then and then we can combine those groups. Okay, and now what we have to put? Okay, the bit which is differ, we have to put dash there. Okay, let me show you the again example, then you can easily understand how we have to do. Now what we have to do, this is our step 3. We have to compare each term of the lowest index group with every term in the succeeding group till no change. Okay, so this is the pair, and this is our answer. And in our answer, we have the binary representation. This is my A, this is my B, this is my C, and this is my D. Okay. So what is rule 3 says? Again, I am repeating. We have to compare each term of the lowest index group with every term in the succeeding group. And we have to combine them by using combining theory. And how we have to combine them? Okay. So two terms from the adjacent groups are combinable. The two terms of the adjacent groups are combinable if their binary representation are differ by only just by a single bit, just by a single digit. So you can see we have to check the succeeding group. So index 0 with index 1. So in index 0 we have 0, index 1 we have 1 and 8. So you can check the binary number. A is 0 for both, B is 0 for both, C is 0 for both, 0 and 1. But D is changing from 0 to 1. So only one bit is changing. So now there is a possibility of combining these two. Only one bit is changing. So now there is a possibility of combining these two. So for 0 and 1, only D is changing. So the bit which is changing, so now these two combine 0 and 1. So my A, B, C is remain same and its value is 0. So 0, 0, 0, and the bit and the bit which is changing, we have to put dash there. We have to put dash there. Okay. Now again, let me erase those things. Now, check for the 0 and 8. So first bit A is changing from 0 to 1, B remains same, C remains same, D remains same. So again there is a possibility of 0 and 8. Again there is a possibility of 0 and 8, and only first bit is changing from 0 to 1. So we have again a pair of 0 and 8, and the bit which is changing, we have to put dash there. We have to put dash there, and all the other threes remain same. All the other threes remain same. Okay. Now the index 0 and index 1 is complete. Now we have to check in which index 1 and index 2. So check 1 with 6 and 9, and then we have to check 8 with 6 and 9. So 1 with a 6 and 9. So 1 we have a 0, 0, 1. 6 we have a 0, 1, 1, 0. So first A is remain same, 0, 0. But B is changing from 0 to 1. C is changing from 0 to 1. And D is changing from 1 to 0. So now the pair is not possible. What is the rule for pair? The pair is only possible if the group is changing by only one bit. Group is changing by only one bit. So 1 and 6 is not possible. 1 and 6 is not possible. Now check 1 and 9. So this A is changing from 0 to 1. So 1 bit already changed. B is remain same, 0 to 0. C is remain same, 0 to 0. And D is remain 0 to 0. Okay, so all other three B, C, D is remain same. All other three B, C, D is remain same. Only A is changing from 0 to 1. So now there is a pair of 1 and 9, pair between 1 to 9, and only A is changing from 0 to 1. Only A is changing from 0 to 1. So the bit which is changing, put there dash. The bit which is changing, put there dash. So A is changing, all other threes remain same, and its value is 0, 0, 1. Okay, so possibility of 1 with a 6 and 9 is checked. Now we have to check the possibility of 8 with a 6 and 9. Eight with a 6 and 9. So these two you can see. A is changing from 1 to 0. B is changing from 0 to 1. C is changing from 0 to 1. So again there are 3 bits are changing. Again there are 3 bits are changing. So the pair of 8 and 6 is not possible. The pair of 8 and 6 is not possible. The pair is only possible if there is a change in only one bit. If there is a change in only one bit. Okay. Now again check with 8 and 9. So the first one is remain same 1, B is remain same 0, C is remain same 0. Only D is changing from 0 to 1. So only one change is there. So now there is a possibility of 8 and 9. Now there is a possibility of 8 and 9. The pair is possible between 8 and 9. Pair is possible between 8 and 9. And which bit is changing? The D is changing. Okay, D is changing from 0 to 1. So bit which is changing, we have to put dash there, and all other 3 bits remain same. All other 3 bits remains same. So other 3 bits is 1, 0, 0. And the D is changing, so I am putting dash there. So I am putting dash there. So now the possibility of index 1 and index 2 is checked. Now we have to combine a group or check the possibilities between index 2 and index 3. So now we have to check the possibility of 6 with all others 7, 13 and 14, and then we have to check the possibility of 9 with all others 7, 13 and 14. Okay, I will check it. Before that, anyone having any doubt in this page 01891989, how it will be there? Anyone having any doubt? Or otherwise it is clear, please write down a clear, so I will move forward. We have to check index 0 with index 1, 1 with a 2, 2 with a 3, and 3 with a 4. And how the pair is possible? We have to check all the 4 binary numbers, and if the binary numbers are differ by only 1 bit, if the binary numbers are differ by only 1 bit, then and then pair is possible. Then and then pair is possible. So anyone having any doubt? Okay. So let me move further. So now we have to check index 2 with index 3. So we have to check the mean terms of index 2 with the mean terms of all the index 3. So now we can check 6 with a 7. So let me give you a shortcut. For a pair, how the pair is possible? So we have to check. Very good, Keval. 6, 7, 6, 14, 9, 13. Yes, it's correct. Okay. Now what we have to check? We have to subtract this mean term 0 minus 1, 0 minus 8. And if your answer is in between, is minus 1, minus 2, minus 4 and minus 8, then there is a possibility of pair. Then the pair is possible. Okay, you can see 0 minus 1. So my answer is minus 1. So again minus 1 is there. So pair of 0, 1 is possible. 0 minus 8. So my answer is minus 8. So pair is possible. Then again 1 with a 2. Okay, 1 with a 2. So 1 minus 6. 1 minus 6, my answer is minus 5. So pair is not possible. 1 minus 9. 1 minus 9, my answer is minus 8. So pair is possible. So see, 1 and 6, pair is not possible. Only 1 and 9. Then 8 minus 6. 8 minus 6, answer is plus 2. Answer is plus 2. What my answer should be? Minus 1, minus 2, minus 4 and minus 8. Then and then pair is possible. So 8 and 6 is not possible. Then 8 minus 9. 8 minus 9, minus 1. Again, pair is possible. 8 minus 9, minus 1, pair is possible. Now check 2 with a 3. So 6 minus 7. 6 minus 7, my answer is minus 1. So pair is possible. 6 minus 13. 6 minus 13, my answer is minus 7. So pair is not possible. 6 minus 14. 6 minus 14, my answer is minus 8. So possible. Then 9 minus 7. 9 minus 7 plus 2. If it is plus 2, it is not considered. If my answer is minus 1, minus 2, minus 4 and minus 8, then and then pair is possible. So 9 minus 7 plus 2 not possible. 9 minus 13 minus 4. So minus 4, so pair is possible. 9 minus 14 plus minus 5. So minus 5, so not possible. So this is a shortcut for that. You have to subtract the min terms of a lower index with a higher index. So 0 minus 1, 0 minus 8, 1 minus 6, 1 minus 9, 8 minus 6, 8 minus 9. And if your answer is minus 1, minus 2, minus 4, minus 8, then and then pair is possible. Otherwise, we have to check. Otherwise, we have to check each and every bit, and the bit which is differ by only one bit, the bit which is differ by only one bit, that then the pair is possible. Okay, we can check 9 and 7. For 9 and 7, nine and 7, 1 to 0, A is changing, 0 to 1, B is changing, 0 to 1, C is also changing, D is only 1. So 3 bits are changing, that's why 9 and 7 pair is not possible. For 9 and 13, only one bit is changing, bit is changing, that's why it is possible, okay. Keval gives the right answer and the 9 and 30. Okay, now we have to check index 3 with index 4. Index 3 with index 4. Okay, Keval already gives the answer. We have to check 7 and 15. So A is changing from 0 to 1. Here BCD 111. Here also BCD 111. So all the 3's remain same. Only A is changing. Only A is changing. So there is a possibility of a 7 and 15, and A is changing. So the bit which is differ by 1, the bit which is differ by 1, the bit which is differ by 1, we have to put dash there. We have to put dash there. Okay. So we are putting a dash to the A. Then we have to check 13 and 15. A remains same 1. B remains 1. Only C is changing from 0 to 1. So we have to put dash there. So 1, 1, dash 1, and also 14, 15. Only D is differ by 1. So 1, dash. So now anyone having any doubt how to make a column 2? See, in the example, first we have to make a column 1. So we have to arrange all the main terms which is given in the example in the index wise, index 0, index 1, index 2, index 3 and index 4. And how we have to arrange those? We have to convert those into a binary. So in a binary representation, those who have only one ones available in a binary, those are in index 1. Those we have 2 ones in a binary, those they are coming in the index 2. Those who have a 3 ones in a binary, those who have a 3 ones in a binary, those they are coming in index 3. And those who are coming, those who have all the 4 ones, they are coming in the index 4. and then we have to check a pair. How we have to check a pair? We have to check a pair with compare each term of the lowest index group with with every term in the succeeding group. So in index 0 we have only one term, and index 1 we have two terms. Okay. So this is about column 2, and how we have to make a group, how we have to make a group, or how we have to combine this. So we have to arrange all the mean terms, and we have to check if their binary representation are differ by only just a single bit. If their binary representation is differ by only just a single bit, then and then the group is possible. Okay. So now again move for the rule. So this is the up to the rule 3 we covered. Okay. Now what we have to do, we have to follow the same process, but now instead of index column 1, we have to come to the column 2. So what is the rule says? Compare the terms generated in step 3 in the same fashion. Means why again we have to check the binary numbers of a group 2, and if the binary numbers are differ by only one bit, then there is again we have to combine those groups. Okay. So the rule says compare the terms generated in step 3. Compare the terms generated in in step 3 in the same fashion. Combine the two terms which is differ by only single one, and whose bases are in same position. Okay, and whose bases are in the same position. So we have to check if the bases are in same position, then and then we have to check either there is a change in only single bit or not. So two terms with the bases in different position cannot be combined. Focus on this rule. Okay. Focus in this line. It is very much important. The two terms with bases in different position. Cannot be combined. Okay. So write the new terms in a column 3. So now we have to make a column 3 and put a check mark next to each term which has been combined in column 2. Continue the process with terms in column 3 and 4, etc. up to the end, until we have to process the same thing until the further combination are not possible. Okay. So again, this is our example. So we are listing all the mean terms and we are converting all the mean terms in the binary form. Then we have to arrange this in a group 1. So in column 1, we have to arrange all these given mean terms in index wise, and in index wise we have to count the numbers of ones available in the binary form. So in index 1, the mean terms are there which having a numbers of 1 is 1. In index 2, the mean terms are in that group which having a numbers of ones in a binary representation is 2. In index 3, in this, the mean terms which having a 3 numbers of ones, or the numbers of ones 3, and the index 4, the numbers of ones is 4. In column 2, we have to make a group. So we have to compare each term of the lowest index group, with every term in the succeeding group. Every term of the succeeding group till no change. And how we have to combine? If their binary representation are differ by only one bit. If is differ by only one bit, then and then we have to combine there and convert into a pair. So we have a pair of 0, 1, 0, 8, same with 1 and 9 and 8 and 9. Just we are checking, then we have a pair of 6 and 7 and 6 and 14 and 9 and 13 and 7, 15, 13, 15 and 14, 15. Okay. Now we have to make again the same thing we are doing, repeating the same. We have to repeat the same thing. Okay, we have to repeat the same thing. So again, the step 4, what step 4 says? Compare the terms generated in step 3 in the same fashion until no further combination. So now in this, you have to focus. The rule completely said that the two terms with a dashes in different position cannot be combined. The two terms which having a dashes in a different position cannot be combined. So now what we have to focus? We have to focus on the dashes only. We have to, very good Keval. We have to focus on dashes only. So you can see in 0, 1 we have a dash at D. So which other having a dash at D? 8, 9. Other 6, 7. Other 14 and 15. So now we have to check the remaining 3, A, B, C. If it is differ by only one bit, then and then another pair is possible. And now instead of pair, it becomes a quad. And instead of pair, it becomes a quad. So you can see. So first we can check 0, 1, and the dash which having the same position at 8, 9. Okay, 0, 1, and 8, 9. So we have a dash at the common place, but now all other 3 bits we have to check if it is differ by only 1 bit. So my A is changing from 0 to 1, so 1 bit is already changed. But B is remain same 0 and C is remain same 0. So only 1 bit is differ. Only 1 bit is differ. So the quad is possible 0189. Now I can check, or now we can check another possibilities of the same dash. So you can see the first bit remains same 0 to 0, but B is changing from 0 to 1 and C is also changing from 0 to 1. So 2 bits are changing for 0, 1, 6, 14, so not possible. And you can easily see I do not have to compare dash at a common place, so 0, 1, 14, 15, only dash is common. All the other 3 are changing from 0 to 1. So there is only possibility of quad is 0189. Now again, we have to check the dash with the common place. So we have 0819 same dash, 614 same dash, and 715 same dash. So you can see again only 1 bit is changing. So dash is common at A. Only D is changing. B and C is remains 0, 0. So see which are the min terms it have 0819 and it is already come 0189. So 0189 is already there. 0189 is already there, so no need to write again. Okay. Now we have to check here. These all 4 are coming there, already there. So now this dash 6, 7. So dash at the last place. So we already checked with 0, 1, so no need to check with 0, 1. Now we will check with 14, 15. We have to check with 14, 15. So 6, 7, 14, 15. So only A is changing from 0 to 1. Only A is changing from 0 to 1. B and C is remain 1, 1. So again there is a possibility of 6, 7, 14, 15. So already we have a dash at the last place D, and now A is also changing. A is also changing, so we are also putting dash there. So again 6, 7, 14, 15 come. So now again we have to check the dash at the first place 6, 14, 7, 15. So we already have 6, 7, 14, 15. So in these two also, those min terms are there, 6, 14 and 7, 15. Okay. So now remaining is, you can see the remaining is 9, 13, which having a dash at a B. So no other term having a dash at the B. So it remains as it is. And another is 13, 15, which having a dash at a C. So no another pair which having a dash at a C. So the final answer is, this is compulsory. You can say it is P, it is Q. These two is not combined with anyone, so R and S. P, Q, R and S. P, Q, R and S. So now we have a step number 5 also, but we end this up to step 4 today. Okay, tomorrow we will check the step 5 and we also solve the another example of a tabulation method. Because we do not have I do not have a more time for step number 5, how it will be there, because it's already 1:57. So we have only 3 minutes remaining, so it is difficult to solve that in or teach you in 3 minutes. So anyone having any doubt in this today's example. Okay, we also take another example tomorrow, so you can easily understand how it is possible. Okay, so we have to follow the rules and move to step by step. And if, let me know you, if your example, sorry, if your exam is online mode or MCQ mode, the tabulation method will be not asked anyway. Okay, there the rules is they will ask the rules, I think, but the process, whole example, they will not ask because this is the example of 7 marks, which is time consuming. If you want to solve the example of a tabulation method, you minimum required 15 minutes. Okay, so the time required between 15 to 20 minutes. Okay. So anyone having any doubt, so you can let me know. And if it is clear, please write down clear. Then we will move forward. See, Keval, you are really correct. You give the pairs name. You are giving the quad names also. But the quad names you are giving is 0189 and the 0819. So both are having the same mean terms. So we have to write for ones only. We have to write for ones only. Okay. The step number 5 is very easy. It will take 5 minutes, but I don't have a 5 minutes. That's why today I will end the session. So tomorrow again we have a session at 12. So we solve the example and another examples. Okay, so thank you everyone for attending the session. So now I request all of you, so between 1 to 10, please write down your enrollment number for the attendance. Between 1 to 10. Okay. 11 to 20, 21 to 30, 31 to 40. Okay, yes. You do not have to write yes. You have to write your enrollment number. Okay, 41 to 50, 51 to 60, 61 to 70, 71 to 80, 81 to 90, 91 to 100. All others, those who have pending, please write down your enrollment number for attendance point of view. And those who already returned, if they want to leave the session, they can leave the session. Yes, Nupur, what's your number? You are already written, it's 27. You have any doubt, Nupur? Okay. Hello.